Hi everyone, it's Mr. Burris. We're going to go over a new topic today titled The Land. Landforms. Do you know the difference between a valley and a volcano? Can you tell a peninsula from a plateau? Landforms are shapes on the planet's surface such as hills or mountains. Landforms make up the landscapes that surround us, whether it's the rugged mountains of central Colorado or the flat plains of Oklahoma. Earth's surface is covered with landforms of many different shapes and sizes. Some important landforms include mountains, land that rises higher than 2,000 feet, valleys, areas of lowland located between mountains or hills, plains, stretches of mostly flat land, islands, areas of land completely surrounded by water, peninsulas, land surrounded by water on three sides. Because landforms play an important role in geography, many scientists study how landforms are made and how they affect human activity. Forces below Earth's surface. Geographers often study how landforms are made. One explanation for how landforms have been shaped involves forces below Earth's surface. Earth's plates. To understand how these forces work, we must examine Earth's structure. The planet is made up of three layers. A solid inner core is surrounded by a liquid layer, or mantle. The solid outer layer of Earth is called the crust. The planet's continents, or large landmasses, are part of Earth's crust. Geographers use the theory of plate tectonics to explain how forces below Earth's surface have shaped our landforms. The theory of plate tectonics suggests that Earth's surface is divided into a dozen or so slow-moving plates or pieces of Earth's crust. Some of the plates, like the Pacific Plate, are quite large. Others, like the Nazca Plate, are much smaller. These plates cover Earth's entire surface. Some plates are under the ocean. These are known as ocean or oceanic plates. Other plates, known as continental plates, are under Earth's continents. Why do these plates move? Energy deep inside the planet puts pressure on Earth's crust. As this pressure builds up, it forces the plates to shift. Earth's tectonic plates all move. However, they move in different directions and at different speeds. The movement of continents. Earth's tectonic plates move slowly, up to several inches per year. The continents, which are part of Earth's plates, shift as the plates move. If we could look back some 200 million years, we would see that the continents have traveled great distances. This idea is known as continental drift. Earth's continents are still moving. Some plates move toward each other and collide. Other plates separate and move apart. Still, others slide past one another. Over time, colliding, separating, and sliding plates have shaped Earth's landforms. Plates collide. As plates collide, the energy created from their collision produces distinct landforms. The collision of different types of plates create different shapes on Earth's surface. Ocean trenches and mountain ranges are two examples of landforms produced by the collision of tectonic plates. When two oceanic plates collide, one plate pushes under the other, creating a subduction zone. This process creates ocean trenches. Ocean trenches are deep valleys in the ocean floor. Near Japan, the Pacific Plate is slowly moving under other plates. This collision has created several deep ocean trenches, including the world's deepest trench, the Mariana Trench. Ocean plates and continental plates can also collide. When this occurs, the ocean plate drops beneath the continental plate. This action forces the land above to crumple and form a mountain range. The Andes in South America were formed when the South American and Nazca plates collided. The collision of two continental plates also results in mountain building. When continental plates collide, the land pushes up, sometimes to great heights. The world's highest mountain range, the Himalayas, formed when the Indian plate crashed into the Eurasian plate. In fact, the Himalayas are still growing as the two plates continue to crash into each other. Plates separate. A second type of plate movement causes plates to separate. As plates move apart, gaps between the plates allow magma, a liquid rock from the planet's interior, to rise to Earth's crust. Lava, or magma that reaches Earth's surface, emerges from the gap that is formed. As the lava cools, it builds a mid-ocean ridge or underwater mountain. The separation of the North American and Eurasian plates formed the largest underwater mountain, the Mid-Atlantic Ridge. If these mid-ocean ridges grow high enough, they can rise above the surface of the ocean, forming volcanic islands. Iceland, on the boundary of the Eurasian and North American plates, is an example of such an island. Plates slide. Tectonic plates also slide past each other. As plates pass by one another, they sometimes grind together. This grinding produces earthquakes, sudden violent movements of Earth's crust. Earthquakes often take place along faults or breaks in Earth's crust where movement occurs. In California, the Pacific plate is sliding by the edge of the North American plate. This has created the San Andreas Fault Zone, an area where earthquakes are quite common. The San Andreas Fault Zone is one of many areas that lie along the boundaries of the Pacific plate. The frequent movement of this plate produces many earthquakes and volcanic eruptions along its edges. In fact, the region around the Pacific plate, called the Ring of Fire, is home to most of the world's earthquakes and volcanoes. Forces on Earth's surface. For millions of years, the movement of Earth's tectonic plates has been building up landforms on Earth's surface. At the same time, other forces are working to change those very same landforms. Imagine a small pile of dirt and rock on a table. If you poured water on the pile, it would move the dirt and rock from one place to another. Likewise, if you were to blow at the pile, the rock and dirt would also move. The same processes happen in nature. Weather, water, and other forces change Earth's landforms by wearing them away or reshaping them. Weathering. One force that wears away landforms is weathering. Weathering is the process by which rock is broken down into smaller pieces. Several factors cause rock to break down. In desert areas, daytime heating and nighttime cooling can cause rocks to crack. Water may get into cracks in rocks and freeze. The ice then expands with a force great enough to break the rock. Even the roots of trees can pry rocks apart. Regardless of which weathering process is at work, rocks eventually break down. These small pieces of rock are known as sediment. Once weathering has taken place, wind, ice, and water often move sediment from one place to another. Erosion. Another force that changes landforms is the process of erosion. Erosion is the movement of sediment from one location to another. Erosion can wear away or build up landforms. Wind, ice, and water all cause erosion. Powerful winds often cause erosion. Winds lift sediment into the air and carry it great distances. On beaches and in deserts, wind can deposit large amounts of sand to form dunes. Blowing sand can also wear down rock. The sand acts like sandpaper to polish and wear away at rocks. Earth's glaciers also have the power to cause massive erosion. Glaciers, or large, slow-moving sheets of ice, build up when winter snows do not melt the following summer. Glaciers can be huge. Glaciers in Greenland and Antarctica are great sheets of ice up to 2 miles thick. Some glaciers flow slowly downhill like rivers of ice. As they do so, they erode the land by carving large U-shaped valleys and sharp mountain peaks. Glaciers crush rock into sediment and can move huge rocks long distances. Water is the most common cause of erosion. Waves in oceans and lakes can wear away the shore, creating jagged coastlines like those on the coast of Oregon. Rivers also cause erosion. Over many years, the flowing water can cut through rock, forming canyons or narrow areas with steep walls. Arizona's Horseshoe Bend and Grand Canyon are examples of canyons created in this way. Flowing water shapes other landforms as well. When water deposits sediment in new locations, it creates new landforms. Rivers create floodplains when they flood their banks and deposit sediment along the banks. Sediment that is carried by a river all the way out to sea creates a delta. The sediment settles to the bottom where the river meets the sea. The Nile and Mississippi rivers have created 2 of the world's largest river deltas. Landforms influence life. Why do you live where you do? Perhaps your family moved to the desert to avoid harsh winter weather. Or possibly one of your ancestors settled near a river delta because its fertile soil was ideal for growing crops. Maybe your family wanted to live near the ocean to start a fishing business. As these examples show, landforms exert a strong influence on people's lives. Earth's landforms affect our settlements and our culture. At the same time, we affect the landforms around us. Earth's landforms can influence where people settle. People sometimes settle near certain landforms and avoid others. Many settlements are built near fertile river valleys or deltas. The earliest urban civilization was built in the valley between the Tigris and Euphrates rivers. Other times, landforms discourage people from settling in a certain place. Tall, rugged mountains like the Himalayas and harsh desert climates like the Sahara do not usually attract large settlements. Landforms affect our culture in ways that we may not have noticed. Landforms often influence what jobs are available in a region. For example, rich mineral deposits in the mountains of Colorado led to the development of a mining industry there. Landforms even affect language. On the island of New Guinea in Southeast Asia, rugged mountains have kept people so isolated that more than 700 languages are spoken on the island today. People sometimes change landforms to suit their needs. People may choose to modify landforms in order to improve their lives. For example, engineers built the Panama Canal to make travel from the Atlantic Ocean to the Pacific Ocean easier. In Peru, people who farm on steep hillsides cut terraces into the slopes to create more level space to grow their crops. People have even built huge dams along rivers to divert water for use in nearby towns or farms.